Hey there, kiddos. Here is your video for solutions to linear equations. So we're going to walk through some examples together really quick. The first example you have here gives you an equation. It says, given the equation y equals 2x plus 1, complete the table to find some of the solutions to the equation. Well, before we talk about finding solutions, let's talk about what a solution is. A solution to a linear equation. Solution is any point that makes the equation true. So when I say I'm going to complete the table so I can find solutions, what I'm looking for are points that make the equation true. So I have that equation, y equals 2x plus 1, and I'm going to complete the table to find some of the solutions. So they tell me what x equals, and I'm going to plug that in to find out what y equals. So this process part, it's 2x plus 1, so I'm going to do 2 times negative 2 plus 1. Well, that makes negative 4 plus 1, which is negative 3. So the point is negative 2, negative 3. And then I'll do it again. So I have 2 times negative 1.5 plus 1. Well, that makes negative 3 plus 1, which is negative 2. So I have negative 1.5 comma negative 2. And then if I plug in 0, I know I'm skipping because I feel like if I do the whole table, you're going to be like, yeah, I get it. So 2 times 0 plus 1, well, that makes 0 plus 1 is 1. So that point would be 0 comma 1. And I could continue with this table. I could continue plugging in the value, getting y, and then writing my point. All of these points that are listed over here in the right column, these are all solutions because all of those points make that equation true. And I know it because I plugged the number in to get the answer. They all work. So the question number 2 says, are these the only solutions to the equation? Well, no. Because I could pick any number that I could think of, 950 million. I can plug it in for x and get a value for y. So there's an infinite number of solutions. It just depends on where I want to stop and start that line. And the reason why is because there are an infinite number of points on that line. So number 3 just gives me a point. It says, is 6.5 comma 14 a solution? Yes or no? Well, we're going to plug it in and see. The x value for this is 6.5 and the y value is 14. So I want to know if I plug this in, 14 for the y is equal to 2 times 6.5 plus 1. If I do this calculation, is this right side going to equal 14? Well, 2 times 6.5 is 13 plus 1 makes 14. So 14 equals 14. So yes, it is a solution because that works. So let's skip over here to question number 4. It's the same kind of problem. They say, is negative 2 comma 1 a solution? And we're going to have to justify our answer. So I'm just going to plug in what I know. X is negative 2, y is 1. So I'm going to do 3 times negative 2 plus 1. I just plugged in negative 2 for x and 1 for y equals negative 5. So we'll check that. That makes negative 6 plus 1, which is negative 5, equals negative 5. So yes, this works. So yes, it's a solution. Now the next question is very interesting because it says, which of these ordered pairs is not a solution to the equation? And there's a couple of different ways to do this problem. We're going to do this by just plugging in our numbers for now. As we get further into this, I will show you there's another way to do it, but right now we're just going to plug in numbers. So I have this first problem. First one, I have my x and my y. I'm going to plug them in. So I have 2 times 3 minus negative 6. Well, minus a negative 6 becomes plus 6. It needs to equal 12. Well, 2 times 3 is 6, plus 6 makes 12. That one is a solution, so A is not the answer. Lather, rinse, repeat. Let's do it again. 2 times 7 minus 2 equals 12. Well, 2 times 7 is 14. 14 minus 2 is 12. That one works. So that's also a solution. So we'll check C. 2 times negative 4 minus a negative becomes plus 18, needs to equal 12. Well, negative 8 plus 18, that makes 10. And 10 does not equal 12, so this one is not a solution. We're going to check D just to be careful, because sometimes there's more than one right answer. Not on the STAR test, but here there might be. So I'm going to have 2 times negative 8 plus, because it's minus a negative 28, and it needs to equal 12. Well, 2 times negative 8 is negative 16. And negative 16 plus 28 equals 12. So this makes 12 and this makes 12. So that's also a solution. So C is my only answer. So number 6 here says, A, solve the equation 4y equals 4x minus 12 given the domain. And they tell you the domain is negative 3, 0, and 1/2. Remember, domain is x. So they're giving me 3 x values. So I'm going to have to solve this problem 3 times. Or I could do it once and use my calculator. So what I'm going to do, I'm going to use my calculator. I'm going to take this and I want to get this letter y, the variable, by itself. Well, to do that, I'm going to have to divide by 4 over here, which means I have to divide both parts of this by 4 as well. So I'm going to end up with y is equal to, well, 4 divided by 4 makes 1x. And 12 divided by 4 makes 3. So I have y equals x minus 3. These are the same equation. All I did was divide it by 4 to make it look different. But if I do that, I can grab my calculator. I'm waiting on it to open. Give me just a second. And so I can grab my calculator and I can press this button. It's lit up red, this button that says y equals. Clear out everything that's in there and let's type in the new equation we just made, which was x minus 3. Well, x is this button right next to alpha. If you push that, it will make an x, and then minus 3. And then what I'm going to do, I have to change a few things. I'm going to press this button that says window. I lied. I'm going to press second and then window. And I'm going to have this thing where it says triangle table. Remember, that triangle means change in, so the change in the table, I want it to change by 0.5 because one of my numbers was a 1/2, and I want to be able to see that. And to look at my stuff, I'm going to do second graph so I can see what's going on with my problem. So the x values it gave me were, it started with negative 3. So if I use my up arrow to go into the negatives, if I go up here to negative 3, you will see that the y value is negative 6. So the range for that is negative 6. My next x value is 0. So if I go to where x is 0 right here, you see that y is negative 3. And then my last one was positive 1/2. So if I go on my calculator to 0.5, which is the same thing as 1/2, I see that y is equal to negative 2.5. And so my next one is negative 2.5. So there are my values. It's negative 6, negative 3, negative 2.5. That's the easiest way to do these kinds of problems. If you can get the y by itself in the equation, you can plug it into y equals, go look at the table and have it tell you what the values are. So for the same equation, I want the value of y if 5 comma y is a solution. Well, if they give me this point, they're telling me x is 5. So I'm just going to plug that into my equation. So I have 4y is equal to, oh, no, I don't want to use that one yet. Let's use this one that we solved for. I have y is equal to 5 minus 3. Well, 5 minus 3 is 2, so the value of y is 2. If I plug it into this original equation, you will get the same answer. It's just going to take you a little more work to get there. So I'm skipping number 7 and 8. I'm jumping straight to number 9. So in the equation, 6.5x plus 1.4y equals 59. What's the value of x when y equals 5? So they're telling me y is 5. So in my equation, I'm going to do 6.5x plus 1.4 times 5 equals 59. And then I'm going to have to do some calculations. So I'm going to have to do 1.4 times 5. And so I have 6.5x plus 7 is equal to 59. And I'm going to solve this equation. I'm going to subtract 7 from both sides. And so I have 6.5x is equal to 52. And then I'll divide by 6.5. And you should get that x equals 8. So if you're going to bubble that in the grid, you don't have to bubble the positive, and you can put the 8 anywhere in here that you want. You can put it at the beginning, you can write it at the end, you can put it in the middle, just as long as the 8 ends up in there somewhere, it's all good. So that is solutions to equations. It's really just plug in the number, see what happens, make it work. We will practice this tomorrow when you guys get to class, and I will see you then.